Hi everybody, Mr. Vidic here. Welcome to our first lesson in the trigonometry unit. As this little overview says in your book here, trigonometry has to do with looking at right triangles and specifically looking at the relationship between the angles and the length of the sides in that right triangle. Okay, I would like everybody to get a ruler out. And on your own at home or wherever you are, I would like you to do this investigation number one here and go through it in detail and measuring all the different line segments that are in this right triangle on the right over here. Okay, and hopefully you're going to get to see the relationship that starts to form between the angle, which is 35 degrees, and the ratio of the length of the sides. Okay. Likewise, do the same thing for investigation number 2. In this case, we have an angle of 58, and you're going to be measuring these distances over here, these line segments, and how they relate to these line segments over here. Okay, moving on. Okay, so let's look at this right angle over here, or rather this triangle here, AOB. Okay, and this triangle has obviously it's a right angle triangle. All of our triangles that we're going to be looking at are going to be right angle triangles. So this is obviously the 90 degrees here, designated by this little box, and we're going to look at this angle X over here. And basically relative to that angle X, we have 3 sides. Okay, we have the side which is the longest side, and that's OB, and that the long side is always called the hypotenuse, or HYP for short. And the longest side is the side that's always going to be diagonally opposite of your right angle there. Okay, all right, then we also have 2 other sides. So that's if I was to label this would be the hypotenuse there. There's also an opposite side, and the opposite side of angle X, that is, so that's directly opposite of angle X. The side that's furthest away is AB, and that's opposite, or OPP here, OPP. Okay, there's a third side down here. Okay, and the third side is the side that's closest to the angle, but that's not the hypotenuse, and that's going to be the adjacent side, and that's marked OA. So let's go ahead and mark that down here. So ADJ designates that side is adjacent. Okay, so again, that's in relationship to the angle X. All right, so the first example says mark on each of these triangles the hypotenuse, the opposite, and the adjacent side relative to the angle. Okay, so our angle down here is angle X over here, and the opposite side is usually pretty easy to get. It's the one furthest away from the angle that's not actually touching it. That's the opposite. The long side is also fairly easy to identify. It's obviously the long one. Sometimes it can get a little bit tricky, but that's always the hypotenuse, is the long side, and then the third one left over is the adjacent, and that's the other one that's touching the angle right here. So this side, what I mean by touching is that the arms of the 2 sides make up the angle. Okay, so those 2 arms, the adjacent arm and the hypotenuse arm, make up that angle. All right, let's look at our angle X over here. Directly opposite would be the opposite side. The hypotenuse would be the long side, and the adjacent side would be over here. Okay, so now there are what are called these special trigonometric ratios, and those those ratios are basically the ratios of the length of the sides. Obviously, any ratio is written in fraction form. If I say there are 5 apples for every 6 oranges, that would be considered a ratio for every 5 apples. And then likewise, you get, as you can kind of tell from your investigation above, you get, you can have 10/12 would be the equivalent ratio. Well, we're doing a very similar thing with instead of apples and oranges, we have just the length of our sides. So we have these ratios over here, and the three that are the main ratio are the sine ratio, the cosine ratio, and the tangent ratio. Okay, these other three over here that are the cosecant, secant, and cotangent, they're just the reverse or the opposite of the first three. So if I were to label these 1, 2, 3, okay, the sine ratio, the cosine ratio, and the tangent, or the tan for short, are the most important ones that you're going to be learning and working with in this unit. And so what are the ratios? Well, the sine ratio is just the length of the opposite side in relation to the hypotenuse. While the cosine is the ratio of the adjacent side, that is the length of the adjacent side, divided by the hypotenuse side. That's the ratio. And you can tell because the hypotenuse is usually always, I should say, the long side, this ratio, sine and cosine, is always going to be less than 1, because the opposite side, the opposite can never be more than the hypotenuse. Okay, the last one down here, the third one, is a tangent ratio, and that is the opposite side divided by the adjacent. So we say opposite over adjacent. And that one can be more than 1 because the opposite side can be longer than the adjacent, as seen in this example over here. The opposite side is longer than the adjacent. All right, so let's look at some actual examples now. First of all, there's this famous acronym which you might have heard, Sohcahtoa, and I'll get into that a little bit later, Sohcahtoa, and that's just to help you memorize these three ratios, and I'm going to kind of tell you how that works in a minute, so you're never going to forget the which one corresponds to which ratio. Okay, I'm going to skip this example of 2, and I'm going to jump right into 3 over here. And it says for the angle A, which is right over here, in the diagram, complete the work below to express the 3 primary trigonometric ratios, so sine, cosine, and tan, as rational numbers and in decimal form to the nearest thousand. So, and again, it kind of reminds you here, you're not going to get this abbreviation here, so you're going to have to memorize all these ratios. So the sine ratio is the opposite side over the hypotenuse. Now that is in relationship to the angle. So let's go ahead and label these 3 sides first. Okay, so this one is the hypotenuse, this one is the opposite, and this one is the adjacent. Okay, and so let's go ahead and put in some real numbers now. The opposite is 20, hypotenuse is 29. So that is the ratio in obviously rational numbers, but let's in rational numbers, but we also want to get it into decimal form, so let's get our calculator out here, which you will need. And so 29 or 20 rather, divided by 29, it's going to be how many decimal places? Nearest thousand, so 0.690 rather, so 0.690. And as I said before, the sine and the cosine ratios can never be more than 1 because the hypotenuse is always going to be longer. Okay, the cosine ratio is adjacent over hypotenuse, and that's going to be 21 over 29. And again, if I get my calculator out, that's going to be 21 divided by 29.724. 0.724, and again, that's less than 1 because the hypotenuse is always longer. Now tan is opposite over adjacent, and that's going to be 20 over 21. And again, to get it into decimals, 20 divided by 21, we see that it's 0.952. Okay, so those are our ratios. Okay, that's the ratio of the lengths of the sides, and those are the three ratios. Now, let me kind of tell you how the Sohcahtoa works. So if I were to write it out like this, so, and then ka, how this works is the sine ratio is designated by the S there, the O is designated by the opposite, and the H is designated by the hypotenuse. Just like over here, the C represents cosine, the A represents the adjacent, and H again is the hypotenuse. And finally, for the TOA, you have T represents the tan, and then OA, opposite over adjacent. So that expression Sohcahtoa is a nice way to remember all three of those trigonometric ratios. All right, let's move on to example number 4 here. We have this triangle PQR, and we're looking at angle X here. So the sine for that angle would be opposite over hypotenuse, so 3 over 5. Sometimes you're going to see it, you know, PR represents the opposite, and PQ represents the hypotenuse. So we just write 3 over 5. And then cosine X would be cosine, remember, is adjacent over hypotenuse. So, you know, it might help to label these right away. A adjacent, hypotenuse, and the opposite. And now you can go ahead and fill in your ratios. That is adjacent over hypotenuse, and that equals 4 over 5. 4 over 5. Likewise, tan would be opposite over adjacent, 3 over 4. Sometimes the trigonometric ratios for an angle are given in terms of the letter at which the angle is located. So for example, the triangle PQR above, we could write Q, sine Q equals 3 over 5 instead of writing X, so that Q would represent that angle there. Okay, so now we have sine A. Again, sine A, label these. So again, hypotenuse, opposite, and the adjacent. And remember, that is in respect to our angle that we're looking at here. So angle A. So sine would be opposite over hypotenuse, so 30 over 34. Cosine would be adjacent over hypotenuse, so 16 over 34. And tan would be opposite over adjacent, so 30 over 16. Example number 6, complete the following. Sine A is right here. You're not always going to get the angle, so just be prepared for that. We have the opposite would be the 1 and the hypotenuse, so let me mark them down. Opposite, adjacent, and the hypotenuse. So 1 over root 2. Cosine would be same thing, 1 over root 2 because it's adjacent over hypotenuse. And tan would be 1 over 1 or just 1. Okay, you can go ahead and do this last one over here. It wants the answer in rational numbers as well, and also in the simplest form. So make sure you simplify your ratios. Okay, well, actually, let me do a couple here. So sine X would be opposite over hypotenuse, so 6 over 10. I'm doing these a little bit quicker now. That would be 3 over 5. Tan Y would be, okay, tan Y would be opposite over adjacent. So now that you guys switch angles, so you guys switch your whole perspective. So now it's in terms of Y, so opposite over adjacent, so 8 over 6 or 4 over 3. Okay, all right, give the rest of these a try, and we'll see you guys in class.